Hello everyone, I am Abhijit Lal, Assistant Professor, Department of EEE, Bhilai Institute of Technology, Durg. Today we are going to study about clamper circuit. The contents for the clamper circuit will be the introduction, then we will see the working of clamper circuit, then we will discuss the different types of clamper circuit, and at last we will compare the basic difference, or we will compare the working of clamper and clipper circuits. So let's see the introduction of clamper. A clamper circuit is used for adding a DC shift to an AC signal. It does not distort the shape of the signal, but only shifts the amplitude of the signal. So this is the basic concept or the basic working of clamper circuit. It does not distort, remove anything from the output, but it simply shifts the DC output within the axis, that means upward or downward, without distorting the shape of the signal. So a clamper circuit is also known as a clamping circuit, which is an electronic circuit that shifts the DC level of a signal without changing the shape of its waveform. And as we all know, suppose if we take an example of an half wave rectifier, if it converts AC into DC, and at the output we are getting output for us any of the one half, that is, suppose for positive half we are getting the output. So what clamper circuit do, it does not distort any of the shape, that means the sinusoidal shape of the output, but it generally shifts it within the axis, that means upward or downward, or it may add the voltage according to that. So this is the basic working of clamper circuit. It moves the volt signal either up or down about the reference level. So as we have discussed, there is a reference level above which the part is called as the positive half, and below that, below the reference level, the negative half is shown. So what clamper circuit do, it either moves the signal up or down with respect to the reference level. So unlike the clipper circuit, it does not change or distort the shape of the waveform. As we have seen in the clipper circuit, it changes the shape of the waveform, which is not done here in the clamper circuit. So it simply adds or subtracts the DC level from the waveform to shift the waveform up or down the 0 volt reference line. Suppose we are taking the reference value or the reference line at 0 volt, then what clamper circuit will do, it will simply add or subtract the DC level, or we can say that level means the voltage. Suppose the maximum voltage in the positive side is 2 volt, and the maximum voltage in the negative side is minus 2 volt. So what clamper circuit will do, it will either increase the voltage from 2 volt to 3 volt and so on, or either it will decrease below the 2 volt, but it will not distort or change the shape of the waveform. It simply adds or subtracts the DC level from the waveform, and that too within the reference level. If it is changing it above the positive half, or it changes the level below the reference line, that is 0 volt line. Now let us discuss about the working of clamper circuit. So the idea behind the clamper circuit is to add the DC component to shift the waveform above the 0 volt line, or subtract the DC component to shift the waveform below the reference line. So either we can shift the voltage above the maximum level or below the maximum level in the negative side. So we are adding or subtracting the DC level from the waveform. So this DC component is introduced in the circuit by utilizing a capacitor, which is the main component of a clamper circuit apart from the diode and resistor. As we have studied in the clipper circuit, the basic component required for the clipper circuit was a diode and a resistor. But one more component is important for the clamper circuit, which is the energy storage component, and that is capacitor. So here capacitor plays the role in adding or subtracting the voltage level, or we can say that the DC level of the waveform. So capacitor is another component which is an important component for the clamper circuit apart from diode and resistor. So a basic clamper circuit consists of a diode, a resistor and a capacitor. Now, the capacitor stores the charge in one half cycle and discharges in another half cycle, where it adds to the input signal and shifts the DC level of the volt signal. So, one working we can understand here of capacitor is that suppose for a positive half the capacitor is storing the energy, or the you can say that store the charges at one half, and during the another half it discharges and it adds to the input signal. In this way the capacitor works and fulfill the function of clamper circuit. Now, let us see the types or the different types of clamper circuits available. So, the clamper circuit can be designed in the following types. We look in the broad category, there are two types of clamper circuits. One is positive clamper and another one is negative clamper. Now, like in clippers we are giving the biasing, the same concept is applicable in clamper also. We can add or subtract or change the value by biasing also, that means applying the external voltage or connecting a battery source to it. So, that biasing process is also included in the clamper circuit. So, that makes the category more broad, and that is with the positive clamper we can apply two types of biasing, which makes the positive clamper with positive biasing and positive clamper with negative biasing. Similarly, negative clamper can be given two types of biasing, which forms first clamper as negative clamper with positive biasing and another one as negative clamper with negative biasing. So, let us study about the positive clamper. So, in a positive clamper circuit, the input waveform is shifted upward above the 0 voltage reference line. The figure shows the circuit diagram of the positive clamper circuit. Here we can see starting from the input side, the signal is sinusoidal, pure sinusoidal wave, which is having the maximum amplitude as Vm and in the positive side, and the maximum amplitude of minus Vm in the negative side. So, when it is passed through a clamper circuit, and that too with the positive clamper circuit, the output obtained is that the waveform is shifted upwards, that means it is shifted above the 0 voltage line. So, now the maximum amplitude in the positive half is 2 Vm, that is Vm, and then above it is 2 Vm, whereas we will not get any output below the reference 0 voltage line or the reference line. So, in this way the positive clamper work. Now, let us see the circuit diagram for the positive clamper circuit. The first is the source denoted by Vi. After that, a capacitor is connected with the diode and resistor connected in parallel. A load present is nothing but a resistive load. So, this circuit diagram shows the basic circuit of positive clamper, which is having the three major components: diode, resistor and capacitor. Now, let us discuss the working in more detail. During the positive half cycle, the diode is reverse bias. Therefore, the input signal appears at the output as it is. At this point, the capacitor is not charged and there is no clamping. Therefore, the output at this half cycle is not considered. And after that, during the next negative half cycle, the diode becomes forward biased and it starts to conduct at this half cycle. So, the capacitor charges up to the peak input voltage Vm with inverse polarity. So, what happened here is that the diode is connected in such a way so that for the positive half of the supply, the diode will be in a reverse bias condition and it will not conduct. So, no output will be obtained at the load side, and during this time the capacitor gets charged to the Vm in inverse polarity, and after that when the negative polarity arises, or we can say that when the negative half of the supply comes, the diode becomes forward biased and the output will at the load side. So, here the voltage will be added up, that means the amount of magnitude of Vm of the supply plus the voltage, or we can say that the charges stored by the capacitor, that is added to the output at the load side. So, during the next positive half cycle, the diode is reverse biased and it does not conduct. Due to this, the capacitor starts to discharge. So, the capacitor discharge adds to the input signal, which appears at the output as the summation of both voltages, which reaches up to 2 Vm. So, we have seen in the waveform the output waveform, we are getting the magnitude maximum amplitude of 2 Vm in place of Vm. So, the additional Vm is coming from the capacitor. So, this is how the signal level is shifted above the 0 volt line, or we can say that the reference line. Now, let us discuss about the biasing in positive clamper. So, the positive clamper can be biased with another voltage source to further shift the input signal waveform. So, as we have seen in a normal positive clamper, the voltage or level is shifted upward the 0 volt. So, if we want to shift it further or make the changes in the level further, biasing is done. So, again there will be the two types of biasing. So, the biasing can be either positive or negative voltage. Therefore, two circuits will be formed. The first one is positive clamper with positive biasing, and second one is positive clamper with negative biasing. So, the biasing applied to the positive clamper forms the positive biasing, further shifts up the waveform, while the negative biasing lowers down the waveform by the amount of the biasing voltage. So, as we have seen in the normal or basic positive clamper circuit, the voltage shifted and the obtained at the output is 2 Vm. So, what positive biasing will do? It will add the voltage to the 2 Vm, and what negative biasing will do? It will reduce the voltage from 2 Vm. So, in this way the biasing helps to further improve or modify the waveform of the positive clamper circuit. Now, let us study one by one the two different types of biasing in positive clamper. So, let us study about positive clamper with positive biasing. So, during positive biasing, a positive voltage source is added in series with the diode as shown in the figure. So, the figure shows that a positive voltage is applied in series with the diode in such a way that a positive side of voltage is connected to the P terminal of the diode. So, this circuit forms the positive clamper with positive biasing. So, here we can see that magnitude obtained is 2 Vm, the voltage obtained is 2 Vm, but it is above the voltage level, that means above the reference point. In normal clamper circuit, we have seen positive clamper circuit, we have seen lowest waveform was touching the reference point, but when a positive biasing is done, is shifted more above the reference line without touching the 0 volt line. So, the circuit is showing the connections for the various components, and input and output waveforms are shown here. So, during the positive half cycle, the diode is reverse biased for the input signal, but forward biased for the battery voltage. Therefore, the diode conducts until the input voltage exceeds the battery. Now, here two conditions arises. We have to see the two source voltages, so that for which the diode will be forward biased. So, for the positive half of the supply, the diode is reverse biased, but the voltage, external voltages, or we can say that the bias voltage applied here makes the diode forward biased. So, the diode conducts until the input voltage exceeds the battery voltage. So, after that what happens? During the conduction, the capacitor is charged with the battery voltage VR1. So, the diode stops conduction once the input voltage exceeds. So, during the negative half cycle, the diode is forward biased for both input supply and battery voltage. Thus, the diode conducts to a charge the capacitor with both the input and battery voltage, that is Vm plus Vr. So, during the next positive half cycle, the capacitor is discharged, that adds to the input signal waveform as explained in the positive clamper circuit. So, in this way waveform at output will be further shifted by applying the positive biasing circuit. Now, let us study about the positive clamper with negative biasing. So, By the name itself, we can see in the circuit diagram shown here, the voltage is connected in such a way that the negative side of voltage is connected to the P terminal, which forms the positive clamper with negative biasing. So, what happened here is that the negative biased positive clamper has the same operation as a positive biased clamper, except the waveform is shifted down by the amount of the battery voltage VR. Suppose the voltage here mentioned is VR for the battery, which is connected in series with the diode. So, as we have seen in the output of positive clamper, the waveform shifted above the reference line, in which lowest portion of the waveform touches the 0 volt line. For positive biasing, that lowest point shifted above by the voltage of the battery. That means, suppose VR is the voltage of the battery, and then the waveform shifted VR above the reference point. So, just opposite will happen with the negative biasing. The waveform, the lowest point of the waveform will go below the reference point by the amount VR. So, this is the working of positive clamper with negative biasing. Now, let us understand in more detail the working of positive clamper with negative biasing. So, during the positive half cycle, the diode is reverse biased due to both input voltage and the battery voltage. So, the diode does not conduct and the capacitor does not charge. So, in this case, what happened is that the two voltages, that is the source voltage and the battery voltage, both acts as a reverse bias condition for the diode. So, diode will not conduct for the positive half, or suppose if we are taking a time period of 0 to pi, it will not conduct. Now, what happens when the negative half came? During the negative half cycle, the diode is forward biased for input voltage, but it is reverse biased for battery voltage VR. Therefore, the diode does not conduct unless the input voltage exceeds the battery voltage, and when the diode conducts, the capacitor charges. So, here in the negative half cycle, a condition arises is that until and unless the input voltage exceeds the battery voltage. So, suppose the input voltage is Vs and battery voltage is Vr. So, until and unless the magnitude of input voltage exceeds the VR, the diode will remain in the reverse bias condition, and as soon as the voltage rises the value of VR, it becomes forward bias and it gives output at the load side. So, in this way the waveform is shifted below the reference point. So, due to this, the charging voltage of the capacitor is reduced to Vm minus VR. During the next positive cycle, the diode does not conduct, thus the capacitor is discharged and the waveform is shifted upward by Vm minus Vr, that is the capacitor voltage. So, the biasing voltage shifts the waveform down by the amount of Vr of a positive clamper. Now, let us study about the negative clamper. The negative clamper shifts the whole input waveform downward with respect to the reference level, which is 0 volt. So, here is the circuit diagram shown in the figure, in which the diode is connected in the opposite direction such that the waveform is shifted downwards the reference line. The whole waveform is shifted the downward side, and the maximum amplitude obtained here is minus 2 Vm, that is for the basic negative clamper circuit, and the upper portion of the waveform touches the reference line. So, this figure shows the input waveform, the output waveform and the basic circuit for the negative clamper. So, during the positive half cycle, the diode is forward biased. Therefore, it conducts and charges the capacitor with inverse polarity up to a peak input voltage of minus Vm. There is no output during this half cycle. So, during the negative half cycle, the diode is reverse bias and it does not conduct. So, in this negative clamper circuit, the diode is connected in such a way that the positive half of the supply will make it forward biased and the negative half of the supply make it reverse bias. So, therefore, the capacitor discharges which adds with the input waveform. So, the addition of both voltages shifts the whole waveform furthermore up to minus 2 Vm. This is how the input signal is shifted downward. So, the basic difference between the positive clamper and negative clamper is that in positive clamper whole waveform is shifted above the reference point, and in negative clamper the whole waveform is shifted below the reference point. Now, let us study about the biasing in negative clamper circuit. So, the biasing can be either positive or negative voltage. Therefore, two circuits will be formed, that is negative clamper with positive biasing and negative clamper with negative biasing. So, the positive and negative biasing of negative clamper further shifts the waveform above or below the reference point or with respect to the reference point. So, let us see the working of negative clamper with positive biasing. So, the figure is showing the circuit for a negative clamper with positive battery source, and the connection is made such that the positive of the battery voltage or the battery is connected to the N terminal of the diode, which makes it the positive biasing for negative clamper, and the two waveforms are shown, that is the input waveform and the output waveform. So, the positive biasing of the negative clamper adds a positive or upward shift by the amount of biasing voltage to the negative clamped waveform. So, as we have seen the negative clamped waveform by the basic negative clamper circuit such that the whole waveform shifted below the reference point and the upper portion of the waveform touches the reference point. So, what positive biasing does here is that it shifts upward slightly the waveform above the reference point, and that amount will be equal to the amount of voltage of the battery. So, it will shift that much amount which is equal to the magnitude of the battery. So, it shifts the waveform up to the positive level due to positive biasing. During the positive half cycle, the diode is forward biased for input voltage, but reverse biased for battery voltage. So, the diode conducts when the input voltage exceeds the battery, and then the capacitor charges. So, the first condition arises for positive half is that the positive half cycle of the input, the diode is forward biased, but it is reverse biased by the battery voltage. So, until and unless the value of Vs exceeds the value of Vr, till then the diode will remain in the reverse bias condition, and as soon as the value of Vs exceeds the value of Vr, the diode gets forward bias and it starts working. So, therefore, the amount of capacitor charge is reduced by the amount of Vr, and the capacitor voltage results in minus Vm plus Vr. During the negative half cycle, the diode does not conduct and the capacitor discharges. So, the sum of input voltage and the capacitor appears at the output, which has a shift of Vr upwards as shown in the figure. So, this is how the negative clamper with positive biasing circuit works. Now, let us discuss the negative clamper with negative biasing. Now, what does it means? The negative clamper shifts the whole waveform below the reference point, and negative biasing further shifts the waveform below the reference point. That means, and that amount depends upon the magnitude of the voltage. So, to form a negative clamper with negative biasing, an external voltage source, or simply we can say that a battery is connected in such a way that the negative of the battery is connected to the N side of diode, which forms it a negative biasing for negative clamper, and the input waveform and the output waveform are shown in the figure along with the circuit diagram of negative clamper. So, the negative biasing of the negative clamper further shifts downward the input signal waveform. So, during the positive half cycle, the diode is forward biased for both the input signal and the battery voltage. So, the connection is made in such a way that both the voltages, that is the supply voltage and the battery voltage, both acts as a forward bias condition for the diode, and so the diode conducts for the positive half. The capacitor charges with the sum of both voltages, that is Vm plus Vr. So, during the negative half cycle, the diodes reverse biases for input voltage, but do not conduct for the battery voltage, but do conduct for the battery voltage. So, during the negative half cycle, the one source voltage acts as a reverse bias for diode, but the battery voltage it conducts for the battery voltage. And what happened here is that when the input voltage exceeds the battery, the diode blocks the signal and it appears at the output, including the discharge voltage of the capacitor. As a result, the waveform further shifts downward as shown in the waveform of the output of the negative clamper circuit. So, in this way, output waveform is further shifted below the reference point using the negative biasing. Now, let us discuss about the applications of clamper circuit. So, the clamper circuit clamps the voltage to increase its amplitude, therefore, it is mostly used as a voltage multiplier. Here the voltages can be increased. We have seen in the positive clamper or the negative clamper, the resultant magnitude increases, it is in positive side or it is in negative side, but the resultant voltage increases. So, due to this, the clamper circuit finds its application as a voltage multiplier. So, here are some applications of the clamper circuit. So, the first application is itself as a voltage multiplier. Next is it is used for improving the reverse recovery time. Reverse recovery time, it is a time duration when any semiconductor device turns off. So, it is a time duration which occurs during the turn off condition of any semiconductor device, whether it is a diode or a thyristor and so on. So, the reverse recovery time can be improved by using the clamper circuit. The next application is used for removing the distortion in the signal. So, if in a signal system or processing, if we have to remove the distortion from a signal, the clamper circuits are used. And lastly, it is used as a test equipment. So, these are the various applications of clamper circuit, and it is widely used in various electronic circuits. Now, at last let us discuss about the difference between the clipper and clamper circuit. So, what is clipper circuit? A clipper circuit clips or removes a portion of an AC signal, whereas a clamper circuit shifts the DC level of the waveform. So, the first basic difference is that a clipper circuit changes the shape of the waveform, or it removes or adds a part in an AC signal, whereas a clamper circuit does not affect the waveform, the shape of the waveform, but it simply shifts the DC level with respect to the reference point. So, this is the basic difference between clipper circuit and clamper circuit. The next difference is a clipper circuit is also known as a voltage limiter or slicer, whereas a clamper circuit is known as voltage multiplier or DC level shifter. So, the clipper circuit clips or removes the portion of AC signal, that is why it is called as voltage limiter, and the clamper circuit adds to the voltage, that means it increases the magnitude, that is why it is called as the voltage multiplier, or simply it is also called as DC level shifter. The clipper circuit is made of diode and resistor. This is the basic difference between clipper and clamper. For a basic clipper circuit, two components are required, that is diode and resistor, whereas in clamper circuit one more component is required, that is capacitor. So, clamper is made up of the combination of diode, resistor and capacitor. So, from this we can see the next difference, that clipper does not require any energy storage component. That means it simply requires diode and resistor. It is not having any energy storage component, whereas clamper consists of capacitor, which is a energy storage device. So, it requires an energy storing component like capacitor. So, in clipper circuit it changes the shape of the waveform, whereas clamper circuit does not change the shape of the waveform. Important difference between the clipper circuit, it changes the shape of waveform, but clamper circuit simply shifts it up and down or adds the magnitude, but it does not change the shape at all. In clipper circuit it does not change the DC level of the signal, whereas clamper circuit changes the DC level of the signal. Clipper circuit it does not change the amplitude of the signal, but clamper circuit changes the amplitude of the signal. The clipper circuit limits the voltage of the signal, whereas clamper circuit amplifies the voltage of the signal. So, the basic work of clipper circuit is to change the shape of waveform, but it does not change the amplitude and it does not change the DC level of the signal, whereas clamper circuit does not change the shape of waveform, but it changes the DC level and changes the amplitude. So, from this we can say that the clipper circuit limits the voltage of the signal, whereas the clamper circuit amplifies the voltage of the signal. And the last difference is that the output voltage of the clipper is always less than its input voltage. This we have seen from the waveforms of the clipper and clamper circuit, and the output voltage obtained in the clipper circuit will be less than that of the input voltage, and just opposite will happen with the clamper circuit, such that the output voltage of the clamper is always greater than the input voltage. As we have seen in the waveform, the magnitude obtained here is the maximum amplitude was 2 Vm, which is more which is just the double of the maximum amplitude of the input wave. So, these are the basic difference of clipper and clamper circuit. And today's lecture we have studied about the clamper circuit and the types of clamper circuit and their waveforms, that how it shifts the level of the output DC above the reference level and below the reference level, and what are the working of biasing circuit, that means positive biasing and negative biasing on the clamper circuit. And lastly, we have discussed the difference between the clipper circuit and clamper circuit. Thank you.